now we have the foundation covered. Tell me more about the first stage of the data lifecycle, collecting data. How do you collect all the data? Are there a lot of different sources that you pull from?
Absolutely. This car company has plenty of IoT devices that are constantly streaming data. And not only are there a lot of data sources that they pull from, but the data landscape is constantly evolving. To not overcomplicate this use case, let's focus on just the vehicle part data. They no longer deal with just large batch files, but they ingest lots of small data chunks in all types of formats. And what they need is a capability to capture all of that data in a consistent manner. They need to not only make sure that they can easily adjust and add new sources to the data stream, but also be able to seamlessly send it downstream to other stages of the data lifecycle for enrichment, reporting, and so on, while assuring that all the security policies for sensitive data are applied. And in the future, they move the processing to the edge, to the machines in the factories, or even their cars, so that if there are any failures, they can make decisions and take action right there and then, in real time and without any delays. In the next demo, our streaming experts will show you exactly how they collect real-time part data from all of their factories using Cloudera DataFlow. Let's take a look.
Hi, I'm Tim Spann. I'm the Principal DataFlow Field Engineer here at Cloudera. Today I'm going to show you how to use Apache NiFi as part of flow management to be able to ingest data from all kinds of edge devices that we have in a number of different factories. We're going to process that data, filter it, enrich it, bring it into Kafka so we could share it with other applications. And then we're going to store it into our operational data store so it can be used by live applications. And then finally, we'll also store a subset of that data that we're going to filter into an object store so we can write some Hive queries. Makes it very easy for you to do this. So I've logged into the system. My first thing to do is go into my environment. There's an environment set up here that I'm using that has streams messaging for Kafka. It has flow management for Apache NiFi. It has an operational database, HBase, that I'm going to use to store the data. So we'll go into it. We had a bunch of these under one environment, and I'm going to first go into Apache NiFi, which you can see here is along with NiFi registry, which we use for version control, which is important when multiple developers are working on an application. So the first thing we're going to do is I've logged in, so I have permissions to my environment, and I'm going to simulate data coming from multiple factories. In the real world, you'd have multiple locations. Maybe they're on premise, maybe they're in different cloud availability zones or in different clouds, or any mixture of those, or even edge devices. We get that data into the system very easily with NiFi, and it's very simple. Now we're going to simulate data here by pulling a large comma-separated value file from an S3 bucket, which is pretty trivial for us to do. But let's show you how that's working. We have something built into NiFi called data provenance, which is extremely important when you're running these distributed applications. You can see exactly what's going on. So we could see here, I just ran this, and I can see, okay, that's the name of the file. Here's a unique ID for it. I could even look at the content if I wanted, but it's 18 megs, so that's a pretty big file. So what we're going to do next is use a live SQL query to take these records in and split them up into 5 different factories. Hence, we're simulating as if this came from 5 different locations, all of them separated by a topic. And we could take a look at one of them to get an idea how you do that. It's very simple to be able to publish data to Kafka in a real-time streaming manner without knowing exactly what that data is. All I know for this use case is it's a comma-separated value, and I'm going to keep it that way. I'm going to send it to this factory 1 topic. I'm going to log in with SSL and with my username. Very easy to do. One thing that we could have done is I could change this out if it was a different type of data. Say it came from a log file, or it was JSON or XML or Avro. Lots of different options when you're dealing with data. What's nice here is with NiFi, I could stop any part of a flow while it's happening. You can't do that elsewhere. I don't have to redeploy, I don't have to restart a service, rebuild something. None of that. Start and stop, never losing data. We've got configurable queues in front and behind all these services. So if you need to make sure something is distributed or load balanced, you can have that for you very easily. So we've taken that data and we've gotten it into Kafka. Now we saw that in the provenance, but let's find a better way of diving into Kafka. We have a tool at Cloudera called Streams Messaging Manager. I'll call that SMM for short, but this is a tool that lets me see everything about Kafka. I could look at all the details around everything going on in my system, how it currently is over different periods of time. I could, just look at one particular piece of data. I could filter it based on who's producing it or who's looking at it. All those things. I could look at brokers. These are all my servers, all my topics. This is how I separate my data. And we're just interested in these factories. This is where the data is. As you saw before, we pushed it into this one, but we've distributed our data between all these to simulate different factories. Let's just go into one to see a little more. So here I could see who produced the messages, how it was partitioned internally in Kafka, data counts, all that sort of metadata and metrics that people really need in operations. As a developer or a data engineer, you're probably more interested in the data. Did my data get in there? And how do I know where it is? And I could see it here. I could search through offsets. It makes it very easy for me to find out what exactly is going on with the system. So I've got data in there. Now let's write our application. And that's about as easy as could be. I have all this stopped. I'm going to start it for you right now live. That's how easy it is. Nothing is broken. Nothing is delayed. Just ready to start things up. And then I can see as soon as I start it, data starts flowing in. Here I'm receiving data from a Kafka topic. The metadata lets me know exactly where it came from, the timestamp, what's the offset, what's that partition. I can look that up if I had some problem I wanted to trace. Also has a unique ID there. And also told me this wasn't just one event. I had a bundle of 4,000 in one chunk coming in. This makes it very performant. You could see here, as it's running, you could see it coming through the queues. Here, I'm going to filter it. Again, keeping with that same comma-separated value, because that worked out well for us. That's what they wanted downstream. Let's keep it that way. I could decide at any time to change this to another format, or split this data out and convert it to other formats later very easily. Here, I'm going to grab everything from this set of events. We call that a flow file. That is a way you group together the data as it's coming in together as individual events or files or packets, whatever is good terminology for you to understand. Here I'm going to query and filter this based on a specific part number and factory. As you see, this is standard ANSI SQL, about as easy as you can be. I'm also going to add another field on the fly by adding it here for that particular query. And then I have another query. I want every record, so you can see no where clause. But I'm going to also add another field. I'm going to use NiFi to create a process timestamp here in this particular format and add that as another field. You couldn't get much easier for that. As you see, nothing's hard-coded. I can make these into parameters. It's a very simple query. It's not hard-coded to one specific type of data. So you see here, one of those routes is going to merge records, again, keeping comma-separated files still, and I'm going to bundle these together to make the file block bigger. It's always nice when you're pushing files out there that have tons of tiny files, and then I'm just going to push it into Hadoop. Cloudera is controlling this for me, so I don't have to worry about security. I use my login, and it will make sure I have proper permissions to store that. And as you see, that was successful. More important, for all the data, I'm pushing it into my HBase operational store so that I could use that for applications and data models, all kinds of things that need that. Let's make sure that data got there. I see that in the provenance. I see the results coming out. But I want to make sure we've got data there. Fortunately, we have Hue that lets me query HBase. I've gone into that inventory table and I could see a ton of records there. Perfect. Everything seems to be working great. Underneath the covers, I want to take a look at how that data is coming through the system. I could see it coming in here, being collected, going into Kafka topics, coming out, being read, being written to HBase. Everything I want is there. This was so easy to do, and I did this built-in streaming pipeline with no code, but I automatically had all the security, monitoring, data governance that I wanted. I could see that lineage and data provenance easily. I got to interact with a cloud-native operational data store and with HDFS for my object store. Very simple. Anyone can do this. Thanks for joining me. Hopefully you'll get to try this very shortly.
Hi, I'm Michael, a product manager in our DataFlow team, and I'll be walking you through new DataFlow capabilities that will be available on CDP very soon. The previous demo, you've seen how easy it is with our current NiFi and Kafka offerings on DataHub to build streaming pipelines. Our customers love how easy it is to build the pipelines today, but are facing challenges to operationalize them in today's dynamic, multi, and hybrid cloud environments. For example, the previous demo collected data from factories. What if you have to onboard new machines or a whole new factory? The data that generated increases, and your data flows have to be able to react and scale accordingly. We're also living in a hybrid, multi-cloud world. More and more organizations are relying on more than one public cloud provider. And when you think about running these data flows across public clouds, you have to be able to deploy them consistently, no matter which provider you choose. You also need to be able to move data from cloud provider A to cloud provider B. And once you're in that hybrid, multi-cloud world, where your data flows are running in completely different environments, central monitoring and alerting becomes critical. You don't want to have a local monitoring console on cloud A and another one on cloud B. You want to have that central dashboard across cloud providers, showing you the health and performance of your flows. So I'm very excited today to announce that we will be releasing a new Cloudera DataFlow service in tech preview for CDP Public Cloud in the next few weeks. And without further ado, I'll jump right into a demo and show you how this new service addresses some of these issues our customers are facing today. So the first thing you might be wondering about after seeing the previous demo where we've seen how easy it is to build these flows in NiFi. So how do I take what I've built in NiFi and run it in this new service in CDP Public Cloud? So let me walk you through how that works. I've built a flow here in a NiFi environment. It's in one process group. It's a very simple flow, reads some data from Kafka, merges records, and writes it to S3. So I now want to run this flow in our new DataFlow service. So I have to get this flow exported. And thankfully, it's very easy to do that. I just have to right-click here, download this flow, and I'll get the JSON representation of all the entire flow logic. Now with that JSON representation, I can switch over to the DataFlow service, and I can import it here into the central catalog. Now think of this catalog as a central repository of DataFlow templates, from where you can start deploying them to any cloud provider you might have to, but also as a place where your developers can discover existing data flows and see whether they can use them for their use cases without just starting over and over again and develop the same logic again. So I've already uploaded our flow definition here, set machine data to warehouse flow, and I want to now go ahead and deploy this in this new cloud service. So I'm just going to hit that deploy new flow button. And now from here, I'm going to select my target environment. So this is for all of you who are managing NiFi deployments today. This makes the deployment process a lot easier. Everything starts with the flow definition, and we go from there. Now, today, I'm going to select this DataFlow demo that's running in AWS. In the future, we'll also be adding Azure and GCP support, so you can truly go from the central flow catalog and deploy these flow definitions to any cloud provider. All right, so clicking continue launches the deployment wizard. The deployment wizard walks me through collecting all the information that the DataFlow service needs to provide this, to deploy this NiFi flow. First things first, I'm going to give it a name and go to the next step. Now, this is probably the most important step in the deployment wizard. So when you move flows from a development environment to production, several things change, right? You're not talking to your development systems anymore. You're now talking to the production systems. So you need to update connection strings. You need to update login information. There might be other parameters that change from development to production. And that's really what this flow parameter step is all about. So you can parameterize your flows at development time and then adjust the values here when you deploy the flow into production. So in my example, I'm going to adjust some security specific properties here. I need to enter some passwords as well, so I can talk to my Kafka cluster. And I also need to upload an AWS credential file so I can write to S3. So this is what I needed to deploy this flow now in my production AWS environment. All right, next step, we pick our deployment size. Super easy. We just pick from one of the predefined node templates here. I'm going to go with an extra small, but since I don't know how much data exactly I'm expecting, I'm going to turn on auto scaling, and I'm going to start with one node initially, and I'll allow this deployment to scale up to 3 nodes. All right, so let's move on to the final step. For all of you out there who are currently responsible for running NiFi flows or other data flows in production, you know that many times meeting a business SLA comes down to tracking a few select but critical metrics of your data flow. And that's exactly what this KPI feature allows you to do. So a lot of our customers, for example, they just want to easily be able to track whether the data flow is reading the amount of data that they expect it to read during normal operation. So in order to do this, we can set up a new KPI on our entire flow. We can select the data in metric here, and we can say, I want to create a trigger and an alert whenever that flow is reading less than 150 kilobytes for 30 seconds. So now I've created that KPI. Could create more, could go even deeper, and can monitor individual metrics of NiFi processors. All right. Last step, review what we've just provided, and I'm going to hit that deploy button. So what now happens in the background is the DataFlow service starts provisioning a new NiFi cluster on Kubernetes, downloads this flow definition, fills in all the parameter values, and then starts the data flow. So while this flow is deploying, let's have a look at our central dashboard that we see here. So this is that central view. We can see all the deployed flows across environments, across public clouds. We can easily see how much data they're reading and how much they're writing to external systems and how that has evolved over time. Now, one deployment sticks out here because it's got a concerning health status. And it's telling me a KPI threshold has been reached. So let's explore this and see what's actually happening here. If we drill deeper here, we see that this flow is actually not reading any data from external systems, but we expected at least 150 kilobytes per second. So what's happening here? Something's not right. Let's go to the actual NiFi flow and see whether we can see anything when we look at that NiFi flow. Now, you might remember this flow. It's exactly the same flow that I showed you earlier and that we've exported and just deployed a few seconds ago. Now, everything looks good here. The processes are running. There's no errors. So our flow deployment here seems to be all right. But what it tells me immediately is that there's something wrong probably with our upstream system. So in this case, I would go ahead, check whether our Kafka cluster is healthy, whether the topic that we're reading from is still receiving data, and that will really help me speed up that troubleshooting process. So let's go back to our dashboard and see what else we can explore here. Apart from these alerts that we've just looked into, for each deployment, you'll be able to easily track the KPIs and the system metrics as well as general deployment-related notifications about scale up, scale down operations, etc. So that central dashboard really gives you everything you need to know about your Flow deployments. Let's recap what we've just seen in the demonstration. So we've seen the Flow catalog. It's very easy to discover templates and kick off the deployment wizard from that central location. Speaking of the deployment wizard, this makes Flow deployment so much easier, simplifies that entire DevOps process, and allows you to enable auto-scaling with a simple button. We've seen how the central dashboard helps you monitor your Flow deployments, KPIs, alerts, notifications across public clouds. I personally cannot wait for all of you to get your hands on this new service and try it out in CDP Public Cloud. Let us know what you think in the chat, and we'd be happy to answer any questions you might have today. Thank you very much.
Now we have the foundation covered.